Hey guys, this is Mr. Teen Tutor here, and today we're going to be talking about a physics concept called momentum. Here's a sample problem for you guys. A 2,400 kilogram car was moving at 4 meters per second when it collided with a stationary 1,000 kilogram car at a stoplight, and the cars stuck together. What was the velocity at which the cars were moving after the collision took place? Before we attack this problem, I want to make sure you guys understand some things about momentum. In particular, the conservation of momentum, which states that momentum is neither created nor destroyed, rather it flows. Now you may have heard something like this from the conservation of matter or the conservation of energy. It's pretty much the same thing. In this case, we're just talking about momentum. And momentum in physics is symbolized, or rather represented, as a capital P, and the equation is mass times velocity. That's how you calculate momentum. And the units for momentum are kilograms per meter per second. Mass, kilograms, velocity, meters per second. And based on the conservation of momentum, we're essentially saying that the initial momentum is equal to the final momentum. So based on that, let's think about our example here. Let's call object A, this is A represents object A, let's call that the 2,400 kilogram car. And let's call object B the 1,000 kilogram car. Now based on what I just said here, that PI equals PF, remember I stands for initial and F stands for final, we're essentially saying that the combined initial momentum of objects A and B is equal to the combined momentum of both objects after the collision has taken place. So for this problem, we're going to use this equation right here. This is going to be a model equation, and it will help us solve this problem. So now with that information in mind, let us now attack this problem. Alright, so let's write our model equation at the top. PAI plus PBI equals PAF plus PBF. And remember that momentum is equal to mv. So now, and remember we said object A is the 2,400 kilogram car, and object B is the 1,000, pardon me, kilogram car. So if we know that P equals mv, we can essentially substitute this in here. So what is the mass of object A? 2,400. And what was its velocity? 4. So 2,000, 2,400 is the mass, times 4, plus, and now let's look at the momentum for object B, which is for the 1,000 kilogram car. What is the mass? Well, 1,000. However, the velocity, you have to read the problem very carefully because you need to notice that it says the word stationary. What does stationary mean? Well, when an object is stationary, that means it's not moving. So if an object is not moving, the velocity is 0. So this term automatically cancels out, but we won't do that yet. Let's finish the equation first. Now we look at the final. We say that PAF is equal to, of course it's the same mass. The mass is not going to change. However, the velocity is different. We're going to call this VF. VF is what we're trying to solve for. Let me make this a little smaller so that we can fit the equation onto one line. So 2,400 times VF plus 1,000. Remember, that's the mass of the object B times VF. Now you notice how I put VF for both of these. Why did I do that? Because if the two objects stuck together and were moving, that means that they have a shared velocity. That's why I put VF right next to both of them. So the velocity is the same for both of them. We just have to solve for that. So now let's isolate the variable like you would do in normal math. So this is 0. That cancels out. So let's see what 2400 times 4 is. It turns out to be 9,600. Now let's look here. Common variable, right? So I just add the coefficients together. So I get 3,400 times VF. Now I divide both sides by 3,400. Let's see what that is. That is approximately 2.83 meters per second. And that right there, ladies and gentlemen, is the final velocity at which the cars were moving at after the collision took place. So this driver right here, the one in the 2,400 kilogram car, not a smart person obviously, because he should have thought about momentum for a second. He should have thought about the fact that hitting this car would be not only catastrophic in some way, but his license could have been revoked. And maybe it was. We don't know. But this guy needs to maybe think about physics and understand things about momentum and the fact that as you go at a greater velocity, the greater the momentum, which is not good if you're going to collide with someone. Well, that's his problem. Anyway, thanks for watching this video. And as for some tips, like I've said a couple of times, when it comes to physics problems involving equations, write the whole general equation out, then sub in the values. Because if you don't write out the general equation and instead you just go to subbing in values, you may encounter a problem because you'll be like, oh, what equation am I trying to use again? You don't want to deal with that problem. So it's important to write the equations out, and it's also important to make note of the important numbers. The 1,000 and the 2,400. But also understand that sometimes teachers may trick you and include numbers that may not be necessary. But nevertheless, you should still take into account the numbers.